Group A, we want to present our mini project on mathematical cryptography. Our title is a new chaos-based fast image encryption algorithm that written by Yong Wang, Kwok Wo Wong, Xiao Feng Liu, and Quan Rong Chen. This journal was published in Applied Soft Computing in 2011 on pages 514 until 522. This journal homepage is www.elsevier.com/locate/esoc. This video project contains introduction, objectives, explanation, and demonstration of the proposed technique, example, results, and conclusions.
Good evening to Sarif. Now I'm gonna introduce about a new chaos-based image encryption and compression algorithm, which known as a new chaos about the base image encryption and compression algorithm is an increasing amount of information that transmitted by internet, not included the source of multimedia, which is text, audio, image, and other files. Other than that, the image will widely used in daily life and be secure. And also, in addition, it will communicate the bandwidth or storage is limited and the data often be compressed. Other than that, the wireless communication network is used. So it may use the low bit rate compression for the limitation of the bandwidth of the algorithm. Other than that, the encryption is performed in privacy, and in image encrypt algorithm is provide the security, the purpose that divide into two groups, which is chaos-based methods and non-chaos-based methods. Non-chaos-based method, so we divided in full encryption or partial encryption, so it may cause the encryption that been selective for the scheme, and the percentage of the data when encrypt are different. Other than that, it will classify, either combine the compression methods or non-compression methods in each data. Other than that, I will summarize it shortly for the part of introduction, which the basic principle of encryption with chaos is ability to produce a sequence of number that are randomly suggested to transform the image decompression, as we'll discuss, and propose the external encryption key to encrypt the important part using one-dimensional chaotic map, and we can provide a compression in terms of correlation between original image, or encrypt the image in three cases which use different multiple keys, and the external keys increase different for each time. Other than that, the overview, the proposed method of selective encryption for the image is based on the discussion of wavelength transform and chaos theory, which is test verification and efficient of the proposed new encryption algorithm for respectively. So it will conclude, this is the conclude simple introduction for the new chaos based image encryption and compression algorithm. So I'm gonna passing the next part for my group mates. Thank you.
5 objectives for our topic. The first one is analyze the statistical properties of a proposed image encryption scheme. Second is aims to demonstrate the robustness of the encryption scheme against statistical attacks through various tests such as histogram analysis and correlation of adjacent pixels. Third is possibility of combining compressions and encryption for improved efficiency in image encryption. Fourth is practical application of the proposed encryption scheme. And final objective, that is 5, highlight its potential for secure transmission of confidential data.
So next, I am going to explain more about the new chaos-based fast image encryption algorithm. During the permutation stage, image pixels relocate without changing their values. In the diffusion stage, pixel values adjust to propagate a minute change across as many pixels as possible. Both phases, shown in Figure 1, require iterative scanning of the image for pixel values. Consequently, each round of the permutation diffusion operation in encryption involves scanning the same image at least twice. This duplication can be eliminated by combining permutation and diffusion operations as illustrated in Figure 2, changing pixel value during relocation to streamline the process into a single image scan, significantly boosting encryption speed and efficiency, which is what the new chaos-based fast image encryption algorithm is. Next, I am going to explain the encryption and the decryption process. The proposed image encryption technique combines permutation and diffusion on image blocks. It utilizes a spatiotemporal chaotic system to generate pseudo-random sequences for both diffusion and shuffling of image blocks. The encryption process involves partitioning the plain image into 8x8 pixel blocks, generating a pseudo-random sequence, applying diffusion by XORing pixel values with the sequence, shuffling blocks, and repeating this step for specified rounds. The decryption process reverses the encryption steps. The encrypted image is partitioned to 8x8 pixel blocks, a pseudo-random sequence generated using the same chaotic system is used to reverse diffusion and permutation operations. Reverse diffusion involves XORing pixel value with the sequence, while reverse permutation shuffle blocks back to their original order. These steps are repeated for specified rounds, and the original image is reconstructed by reassembling the decrypted blocks. So make sure that the decryption process uses the same pseudo-random sequence to ensure accurate reconstruction.
Hey everyone, now I'm gonna explain based on the image. First of all, we can see the problem statement. From the image, we gotta see three problem statements. First one, the problem statement potentially make chaotic image encryption difficult, costly, or challenging. The applications below, environments or areas wherein chaotic image encryption has been demonstrated to be of assistance or efficiency. The technology or branches of science that can support chaotic image encryption via improving its feasibility, security, performance, or cost efficiency. Now I'm gonna explain everyone how the chaos theory used in the cryptography. The chaotic cryptography uses dynamic systems with very complex behavior. On the other one hand, they obtain values from such systems appear to be random, while the way they are obtained is completely deterministic. For these reasons, chaotic mappings have been used in, among other areas, data encryption, such as 2, 3, 4. This one is the data encryption that can be used from the chaos theory. Now I'm gonna demonstrate based on the Enigma machine. Enigma machine. So based on this one, you can see the Enigma machines were a family of portable cipher machines with rotor scramblers. So good operating procedures properly enforced would have made the Blackboard Enigma machines unbreakable. The German Blackboard equipped. Enigma became the principal of crypto system of the German Reich and later of the other Axis powers. The Enigma machine has been known from the World War I since the other countries has been used it, but the German already upgraded till the first Enigma machines has been used while World War II. Until the release of the Oscar-nominated film The Imitation Game in 2014, the name Alan Turing was not very widely known, but Turing's work during the Second World War was crucial. Alan Turing is the first one who knows how to break the code of Enigma machine while World War II. Alright, now I'm gonna demonstrate how the Enigma machine works and the relation between the crypto system. First of all, we gotta know the plug port and the plug connection. So when we connect the plug port, for example, plug Q to the plug E, so the Q will change to the word E when it's gotta move and when it's gotta type from the keyboard. So when there's a lame board where the encryption got be written out, and also the wheels where we can scramble the unit with the letter that we want, and it also can be scrambled automatically with the reversing wheel when we enter the key from the keyboard. So the step is the Enigma achievement stage. First of all, we gotta move to the keyboard. We press the word, for example, T. So it's the plug board. From the T, gotta go to the plug K, for example. Then from the K, we gotta move to the static wheel. First of all, for example, the wheel go to the K, then the wheel number 3 from K to the O, then the middle one, the wheel 2 from the O to the P. Then we gotta move to the left one, the wheel number 1 is moved to the P to the hash. Alright, so every time the keyboard got be pressed, the key also be scrambled automatically. Okay, so from the scrambler, it's gotta move 2 times. So from the word R to the D, and also from D got moved from the left wheel to the middle and to the right till it's going to the static wheel. Then it's gotta move to the plug board, and the last one is gotta move to the lamp board, the encryption that can be written. So this is how we gotta demonstrate and show you guys the Enigma machine works and the relation between the encryption and also decryption from crypto system. Thank you very much.
So, I'll be explaining the example. The first one is the key sensitivity, and the second one is the statistical analysis. So, I'll be explaining the example. The first one is the key sensitivity. A is the plain image, B is the cipher image using key 0123456789012345. C is the cipher image using key 0123456789012346. And next, which is D, is the difference image between the two cipher images. And the last image is the decrypted image using a slightly modified key. A is the plain image, B is the cipher image using key 0123456789012345. C is the cipher image using key 01234567. Here is the conclusion from the example of key sensitivity. In the proposed algorithm, a 1 to 8-bit key is used. The first one, a 512 times 512 image is encrypted by using the test key 0123456789012345. The next, the key is changed slightly to be 0123456789012346 and used to encrypt the same image. Next, the two cipher images are compared pixel by pixel. And then the last one is the decryption fails completely. Here, the number of encryption rounds is selected as R equals to 2. There is a 99.622% difference between the two cipher images. If a slightly modified key is used to decrypt the cipher image, the decryption fails completely. Next, let's move on to the statistical analysis. So, the first one is a plain image, paper. B is the histogram of the plain image of paper. Next is cipher image. And then next, which is D, is the histogram of cipher image. It is well known that passing the statistical analysis on ciphertext is of crucial importance for a crypto system. Indeed, an ideal cipher should be robust against any statistical attack. In order to prove the security of the proposed image encryption scheme, the following statistical tests are performed. First, the histogram. Encrypt the test image paper for 2 rounds and then plot the histograms of the plain image and cipher image as shown. The latter figure shows that the histograms of the cipher image is nearly flat, implying a good statistical property.
For the result, upon encryption, the original plaintext image transforms into image 1. Subsequently, decrypting image 2 using the correct key seamlessly restores the plaintext image. However, the use of an incorrect key during decryption results in the retrieval of image 2 instead of the original plaintext, underscoring the criticality of employing the precise key for successful decryption and data retrieval. Next, when image 1 is converted into a histogram, graph 1 illustrates the grayscale distribution of the original image. Conversely, converting image 2 into a histogram yields graph 2, depicting a uniform distribution of grayscale values within the encrypted image.
For the last part is conclusion. As we all know, we already covered four main things in the article, which is the objective, technique, example, and the result for the article. There are three main things that we can conclude in the development of a novel chaos-based fast image encryption algorithm, such as key achievement, practical implication, and future direction. Our presentation highlights the development of a novel chaos-based fast image encryption algorithm. The algorithm not only ensures robust security for image data, but also boasts an impressive processing speed, addressing the need for efficient encryption in real-time application.